The revolution will be visualized when we can see that if you keep it too hood, then the hood is the only place you are ever going to be.
So far I've told you symmetry decomposes trace formulas. It produces factorization of the spectral determinants. But if you choose to represent your spectrum by our duality formulas, which on the left-hand side you have functions and eigenvalues evolution operator that moves functions and R, and on the right-hand side you have periodic orbits or points in state space. This is a little bit, it's literally like Fourier analysis for a circle, but this is generalization for any nonlinear system. You either look at points, or you look at the dual space, which is good for describing functions defined on these points. That was number one. That was very abstract. Number two, I told you something very specific happens, which is that any time I have a single periodic orbit in a full state space, if there is a symmetry, it decomposes into a product of prime periodic orbit. Totally crazy way. 1 minus Tp is determinant. I will now show you how this works in specific example. The whole course is just linear algebra. I'm telling you the matrices and operators, and we are computing their determinants. What's the big deal? Still, after a while, you don't quite get it. 3-disk billiard is wonderful. We humans can figure out what. So here is a 3-disk billiard. And I'll just take part of 3 disks close to each other, and I'll draw a few obvious solutions. So this is 1, 2, 3. In the full state space, we have a solution that looks like that. It hits disk 1, it hits disk 2, and does it forever. So its symbolic dynamics is 1, 2. Now, the moment you see it, you realize there are 3 copies of that. There's also one that's called 1, 3, and one that's called 2, 3, and one that's called 1, 3. So we find out that we have periodic orbit in a full state space, label 1, 2. And then we have the 2 rotations of that orbit. If I rotate it by 1/3 or 2/3, I get 3 copies of the same thing. So the moment I understand it, I only computed once, and I have 3 copies of it by group theory. Here is another orbit. I start here, I bounce. That's an orbit. It's called 1, 2, 3, and then I repeat. So it's a 3 cycle. Kind of obvious. But actually, I can also go in the opposite direction. So there is also an orbit that says I start at 1, I go to 3, and then I go to 2, and I do it forever. So there is a 3 cycle. And then what is the other guy? Just a flip around the symmetry axis. So that one comes in 2 copies. Now I don't have the patience to draw, it's fairly long, but it's in the book. There is also shorter cycle, which is periodic in full space and also periodic in a fundamental domain, which I haven't shown to you. And that one will show up as 6 copies. So there's a cycle, and then there are 6 copies of it. So that one has no symmetry. So this one has, these guys have flips in it. These guys have rotation. And their multiplicities are given by the order of the group divided by the subgroups of flips. Flip is 2-element group, so they appear in 3 copies, and these guys are order divided by rotations. Rotations 3, so they appear in 2 copies. And then there are ones that have no symmetry, so they appear 6 times. And in this system, in potentials, we could also have the ones that appear only 1 time, but they would sit at the origin, and this doesn't happen here. This is how it works in the big world. Now, in the little world, T1, 2, 3, 2, 3 has 6 copies. Now, this symmetry. With symmetry, we're just sitting in 1/6 of this. You can think of the axis of the problem, this axis and this axis, as the mirror walls. They're not mirrors, but it's group theory. They'll give boundary condition. For emotional reasons, it's good enough. So what happens to these 3 guys? All 3 of these guys are actually cycle of length 1, because you hit the mirror, you come back. So we call this 0. So that's a prime orbit. Half is enough, because after that you repeat. This is a fixed point 1, this 3 cycle. And then you start designing other cycles. It's much, much simpler, and everything works from that. The factorization is in the book.
You will not be able to stay home, brother. You will not be able to plug in, turn on, and cop out. You will not be able to lose yourself on Skag and skip out for beer during commercials, because the revolution will not be televised.